Hello everyone, welcome to another video. In this video, you will learn about how to use first principle to differentiate trig functions. But before I teach you that, there is two rules that you need to remember. One of them is the limit as h approaches 0, sine h over h is equal to 1. You must also bear in mind that the limit as h approaches 0, 1 minus cos h over h is also equal to 0. Now, there is a few fraction skills that you should bear in mind as well. For example, let's say that you have sine of x times cos of x, all of that over 4. You must bear in mind that you could rewrite this as sine of x over 1 multiplied by cos of x over 4. And these two things are the same. You're not changing the value. So let's say you have a function and you have the function f of x is equal to sine x, right? And you're asked to differentiate this function using first principle. Then you know that the first principle rule says the derivative of f of x is equal to the limit as h approaches 0, right? F of x plus h minus f of x all divided by h. That's what the derivative, the first principle rule states. So now we have f of x already in our formula. We need f of x plus h. So f of x plus h is equal to, anywhere you see x in this function, replace it with x plus h. So that's just sine of x plus h, right? But what is sine x plus h? You can use the double angle identity for sine of an angle plus an angle to expand this, right? So if you expand this, this is going to be sine of x cos of h plus sine of h cos of x, right? So f of x plus h is equal to sine x cos x plus sine h cos h. Now we can just go ahead and put it in the derivative formula here. So therefore, the derivative of f of x is equal to the limit as h approaches 0. F of x, what is f of x? F of x is all of this, which is a sine of x cos h plus sine of h times cos of x. All of that minus f of x. But what is f of x? F of x is sine x, right? So it's minus sine x, all of that divided by h, right? Now here we have a term with sine x cos h, and we have a sine x over here. That means we can group those terms together and factorize a sine x out, right? So if you rewrite back what you have, which is f of x prime is equal to the limit as h approaches 0, sine x cos h, bring this over, become minus sine x, then write back the middle term at the end here, plus sine h cos x, all of that now divided by h. We didn't do anything different here. All we did was just to rearrange these to get the terms which have sine x close to each other. Now you can see that there's a sine x here and a sine x here, which is common, which means that I can factor out a sine x. So write back what you have, which is f prime of x is equal to the limit as h approaches 0. If you factor out sine h, you write sine x, sorry, if you factor out sin x, right, sin x, open a bracket, use this sin x to divide the first term. All you will left back with is cos h, because sin x will cancel out sin x, so you're left back with cos h minus sin x into sin x, that's just 1, so that's minus 1, all of that in bracket, plus sin h cos x, right? Now you know that if you are adding two things right here and they are over the same denominator, then you can split it. So I'm going to split it and put h here, keep the plus in the middle, and put sin h cos x over h here as well, right? Now if I split it, what it does, you are now able to identify these rules in both of these fractions here. Cos h minus 1 over h is actually 0, which is this rule here. So all of this is 0. So 0 times sin x, all of that is just 0, right? So we know that the derivative of f of x is equal to 0 plus sin h over h. We know sin h over h, that's just 1. So sin h over h, that's just 1, times cos x, that's just cos x. Right? So we know the final answer is the derivative of f of x is equal to cos x. And that is how you would use the first principle rule to differentiate a trig function. So let's look at another example. Say you have a function which says f of x is equal to cos x, right? What do we need? We need f of x plus h. So we need f of x plus h, which is equal to cos x plus h, right? Anywhere you see x, replace it with x plus h. Can we expand this? Of course. When we expand this using the double angle identity for cos 2x, we know that cos, this is cos x cos h, because this is plus, it's going to take a minus here, and this is going to be sine of x sine of h. Therefore, f of x plus h is equal to cos x times cos h minus sin x times sin h. So we can just fill that up in our formula, right? So the derivative of f of x is equal to the limit as h approach 0, f of x, which is all of this, which is just cos x times cos h minus sin x sin h, subtract cos x, which is just f of x, right? Cos x. All of that must be divided by h, right? Is there anything common here? Yes, there is something common. We have a cos x here, we have a cos h, we have a cos x over there. So we can factor out a cos x, right? Now, we know that the derivative of f of x is equal to the limit as h approach 0. Because my board is small, I'm just going to go ahead and factor out cos h without rewriting the problem. So cos x, if you factor out cos x out of the first term, that leaves you back with cos h. Factor out cos x out of the last term, which is minus cos x, that leaves you with minus 1. Right? Then you write back your middle term, which is minus sine x sine h, all of that divided by h, right? We know that this can be rewritten by splitting h fraction and give it a denominator of h, right? So we know that the derivative of f of x is equal to the limit as h approach 0 cos x open bracket cos h minus 1, all of that over h, right, minus sine x sine h, all of that over h. Now again, you can view this as those cos x over 1 times cos h minus 1 over h, right? Same thing. Now what we're doing is trying to identify these formula in each of them. So here we have cos h minus 1 over h. That's a 0, right? Again, all of this side is just going to be 0. Here, sine h over h is 1, so that's just 1 times minus sine x. So you see the answer already, right? So our final answer is f of x prime is equal to, if all of this is 0, and this part here, let me highlight it. So we know that this part here, all of this is just 0. And we know that 0 times anything gives us 0. So all of this section is already 0. We know that this section here, sine h over h, that's just 1 according to the rule, right? So that's just 1 times minus sine x. So our final answer is just minus sine x. So when you use first principle to differentiate cos x, that's the answer there. Alright, let's look at another example. Let's say you have a function and the function is f of x is equal to sine 3x. And you are asked to use first principle to differentiate this. You know you need f of x plus h, right? Which is equal to, anywhere you see x, replace it with x plus h. So this is now equal to sine of 3 open bracket x plus h, right? Now you can expand this out, right? So if you expand this out, this is now being sine of, distribute this 3 to each term inside of the bracket, that is now 3x plus 3h. Clear there? We can put this in a bracket. Now we still can use the double angle identity for sine to expand this. So if we expand this, we now have sine 3x times cos 3h plus sine 3h times cos 3x, right? So we now know that f of x plus h is equal to sine 3x cos 3h plus sine 3h cos 3x. So now we can go ahead and differentiate the function, right? So the derivative of f of x is equal to the limit as h approach 0. We know we must have f of x plus h, which is all of this. So we must have sine 3x cos 3h plus sine 3h cos 3x minus f of x, which is just sine 3x, minus sine 3x. All of that must be over h, right? I'm going to rearrange this to group the terms with sine 3x close by each other. So, if I rewrite this, I will keep my f of x prime equal to the limit as h approach 0. Right back the first term here, which is sine 3x cos 3h. Move this term with the sign, this becomes minus sine 3x plus the middle term, which is plus sine 3h cos 3x, right? All of this must be divided by h. By rewriting it, it is much easier to see that there is a sine 3x here and there is a sine 3x here. That means you can factor out sine 3x out of this term. So now we would have the derivative of f of x is equal to the limit as h approach 0. Factoring out sine 3x, you write sine 3x, open a bracket. You factor out sine 3x out of the first term, you are left back with cos 3h minus, factor out sine 3x out of sine 3x, that's just 1. Close your bracket. Plus sine 3h cos 3x. What I am going to do, instead of just drawing one straight line and put h, I'm just going to split it from here. So I'm going to put this over h, since they are the same thing, and put this side over h. Now, we know that sine h over h equal 1. And we also know that 1 minus cos h over h equals 0. But we have a problem now. Here we have cos 3h minus 1 over h. And here we have sine 3h over h. That is not 1. Which means that whichever coefficient is beside the h, we need it here. But how can we get a 3 in the denominator? You know, if you have a fraction which is 1 over 2, and you multiply both top and bottom by a number which is, let's say we multiply by 3 over 3, you're not really changing the problem. All you're doing is creating an equivalent fraction. So this is now, if you multiply the numerator here, 1 times 3, that gives you 3, and 3 times 2, that gives you 6. But 3 out of 6 is still a half, right? So you're not changing the problem. So with that knowledge in mind, it means that we can multiply both numerator and denominator by 3 over 3 to get a 3 in the denominator here. So if I multiply this side by 3, I now have, and let me just write that in a different color. So I now have 3 here and 3 here in the denominator. And I will also have 3 here and 3 here in the denominator, because I'm just multiplying both numerator and denominator by 3 over 3, not changing the problem. Right? So now that I have 3h, I now know that all of this part here is actually 0. And 0 times anything gives me 0. So I know that the whole first term here is 0, because we know as the limit as h approach, the limit as h approach 0, 1 minus cos h over h is equal to 0. Here, the limit as h approach 0, all of this here is 0. And we have the limit as h approach 0 here. We know that sine h over h is equal to 1. So here we have that part, which is this part here. we have sine 3h over h. So that's just 1, right? So all of this middle section here is just 1. So what is our answer then? Our final answer is f of x is equal to 3 times 1, which is 3. So that was 3 cos 3x. Cos 3x. And that's it. That is how you would use the first principle to differentiate a trig function. Alright? So let's look at another example. We have f of x is equal to cos 2x, right? We know we need f of x plus h, and that is equal to cos 2x plus h. Right? You're comfortable with this, right? Anywhere you see x, replace it with x plus h. Right? So we know that this, you can distribute this 2 to each term, so this can be simplified to be cos 2x plus 2h. Right? Now we can use the double angle identity to further expand this out to be cos 2x cos 2h. This is plus, this is going to be minus sine 2x sine 2h. Right? So now we are ready to differentiate the function. So the derivative of f of x is equal to the limit as h approach 0 f of x plus h, this is this thing, which is cos 2x cos, it's supposed to be 8, sorry, 2h minus sine 2x sine 2h, all of that minus f of x, which is cos 2x minus cos 2x all over h, right? So the derivative of f of x is equal to the limit as h approach 0. If we factor out a cos 2x, we have cos 2x, right? So we can factor out a cos 2x. Factor out a cos 2x, we have cos 2x, open bracket. Factor out cos 2x out of the first term, we left back with cos 2h. Factor out cos 2x out of minus cos 2x, that leaves us with 1. Right? Minus our middle term here, which is sine 2x sine 2h, right? Instead of writing all of this over h, I'm just going to split it, so it is this fraction over h and this part over h. Same thing, right? Now we have an h here, but for this to equal 0, we know that the same coefficient of the h term has to be in the denominator. So here we need a 2 in the denominator and we need a 2 here. So all we need to do is to multiply both numerator and denominator by 2. So if you multiply this by 2 and this by 2, you have 2h. And you do the same thing here. You multiply both top and bottom by 2. So this becomes 2. This becomes 2 there. Now we can apply this rule. Right? So we know that all of this part here, which is cos 2h minus 1 over 2h, is this rule here, which is a 0. So we know that all of this is actually 0. And 0 times anything is 0. So we know our final answer is going to be the derivative of f of x is equal to, this is just 0, right? All of this term. So I'm not going to write that. So we know that if we look in this term, we know that sine 2h over 2h, which is this part here, all of this is just 1. So in other words, we have minus 2 sine 2x times 1, which gives us a final answer of negative 2 sine 2x. So the derivative of cos 2x is equal to minus 2 sine 2x. Alright? And that is how you use the first principle to differentiate trig function. Thank you for watching, and I hope that you will have benefit from this video. Please remember to like, subscribe, and share this video. Enjoy the rest of your day. Thank you.